do some more when we get to them. To find the exact value of each of the following. So sine theta is 19 over 20, theta is in quadrant 2. So if we're going to find sine of 2 theta, it's 2 sine theta cosine theta. So the first thing we need to do is figure out, hey, what's cosine of theta? So sine theta was 19 over 20. How do we go about getting cosine theta? Yeah, we can make a triangle. So here's theta. Here's 20, 19. So 400 minus 361 is 39. So do you see where I got 400?
Yeah.
Do you see where I got 361? Okay, so this should be square root of 39. So square root of 39 over 20, except it did say in the problem that theta is in quadrant 2, so it's actually negative. Yeah. So sine 2 theta is 2 sine theta cosine theta is going to be 19 times 2 is 38, root 39, 20 times 20 is 400, and it's negative. Sine is negative. So 38 times 39 over 400.
What are you doing?
400. Because it was 20 times 20 on bottom. Something the correct one. Oh, I guess I can reduce that fraction, can I? 38 over 400 would be, well, it doesn't matter. That shouldn't matter. But it does matter that it will reduce, because 38 over 400 is 19 over 200. Okay, cosine 2 theta. So let me use, since they gave me sine and it was nice and simple, let me use the cosine that just has sine in it. So 1 minus 2 sine squared of theta. So 1 minus 2 times 19 over 20 squared. That's 361 times 2 is 722. 800 minus 722 is 78. I think, which would be 39 over 400. Oh, wait, no. I'm being ridiculous. Okay, let's get a calculator. Should have done that the first time. This thing doesn't do fractions. So 19 squared times 2 minus, this will be 400, bless you. So negative 322 over 400, which is 161 over 200. Tangent 2 theta is the easy one because it's just sine over cosine. The 200s will cancel out. We'll have 19 root 39 over 161. Oh, no. Yay. That wasn't too bad, was it? And really the only thing we had to do was get that cosine of theta there at the beginning. That's the exact same thing. Do you want to do one more that's the exact same thing? Okay. So sine is 7 over 25. Yeah, this one's nice because it'll come out even. So cosine theta is, well, 25, 7. 625, if you punch it in, that should wind up being 24. Let's double check. 25 squared minus 49 equals square root 24. Yay. So it's 24 over 25. And we're in quadrant 3. So it is negative. All right. So sine 2 theta. What is the formula for sine 2 theta? Two sine cosine theta. There you go. So 2 times negative 7 over 25 times negative 24 over 25. 7 times 24. I don't know. You got me? Okay. 2 times 7 times 24. Sure. 336. Let's go with it. Nice. Hey, if you had messed up, it'd probably be me telling you what to do. So cosine, we can use either one. Let's just use the sine one. So 2 sine squared. 2 times 7 over 25 squared. So 625 minus 98 is what? $527. And then sine over cosine, so 336 over 527. Hopefully that doesn't reduce. Okay, apparently I have to make my screen big so I can type it in. 336 over 527. Yay! Cool. Does it make sense that the answers are all positive? Wow. So we started off in quadrant 3. If we double the angle, well, quadrant 3 is from 180 to 270. So doubled would be from 360 to 540. So it has to wind up either in quadrant 1 or quadrant 2, I guess. But anyway. All right. Verify the following identity. So, what are my options? Okay. So if I look at the options, there's only one that makes any sense at all. Which one looks like something that's part of our, well, okay. There's 2 of them that make sense. We don't have anything that has 1 plus 2 sine squared in it. But we have 1 minus 2 sine squared, and we have 2 sine theta cosine theta. So, which one goes with something that's in the problem to start with? Bless you. 2 sine x cosine x is the formula for what? That's for sine 2 theta. Yeah. Do we have sine 2 theta in the, no, we have cosine 2 theta.
So it would be 1 minus.
Yeah. So first we're going to change the cosine 2x into 1 minus sine squared x. And that's really all it is. Once you do that, then you combine like terms. So use appropriate double angle formulas to rewrite the numerator, denominator, and the expression on the right. The numerator, use the double angle formula that will produce only one term in the numerator when it's simplified. So I'm going 1 minus, so I want a formula that has a 1 in it, has a positive 1 in it. That way the ones will cancel. So the one that has a positive 1 in it is 1 minus 2 sine squared x. And then what's the formula for sine 2x?
That would be 2 sine theta cosine theta.
Yeah. 2 sine cosine x. Boom. And now they magically cancel. So, and it says enter the denominator from the previous step. So we're not doing anything else. We're just canceling the ones. So we got 2 sine squared x because the ones cancel. And the minus minus makes a plus. And we've still got 2 sine x cosine x. And now that reduces to tangent because the 2's cancel, the sines cancel, so I've just got a sine over cosine, which is one of our quotient identities. Let's go to about 11. Oh. What was your favorite thing to do in algebra class?
Oil.
I think I like Angel's answer better, but I was looking for Courtney's answer. So
I do like angel fancy.
Sleep.
Yeah. You messed me up, Michaela. I called Angel Austin whenever I told him to go get the door for you. It's all your fault.
I'm sorry.
So this one's not too bad. If it was actually, I take that back. This one's not bad at all. So yeah, if it was cosine, we would have to FOIL. We don't even have to FOIL. So
Oh, okay.
it's actually really, really easy. So we want to write this. Wait, no, I'm being stupid. Yes, we do have to FOIL. Okay. So power reducing formulas. I don't know what they're calling power reducing formulas. I guess they're calling the half angle formulas power reducing formulas. So sine squared of theta would be 1 minus cosine 2 theta over 2. So that's another way of writing the half angle formula for sine. So we're just going to do that with this guy here. So we've got 20 sine squared squared, so times 1 minus cosine 2 theta over 2 all squared. So I've got 20 over 2 becomes over 4 when I square it. What's 1 minus cosine 2 theta if I square it? This is algebra. This is not trig. Okay, let's do that. So 1 minus cosine 2 theta times 1 minus cosine 2 theta. I've got 1 minus cosine 2 theta minus cosine theta is minus 2 cosine 2 theta. And then plus cosine squared 2 theta. So I've got 1 minus 2 cosine 2 theta plus cosine squared.
Is that hard to write with a 3?
2 theta. No, that's pretty much my normal handwriting. I mean, partially I was trying to finish off the line before I made it to the, yeah. I mean, I could actually just scoot over it. It would work fine, but you know me, that can be difficult. So 20 over 4 is 5. Yes. So 5 times all that. So far I've got 5 minus 10 cosine 2 theta plus 5 cosine squared 2 theta. So that is my normal handwriting right there. Is that pretty or is that ugly? Okay. All right. Thank you. Thank you. All right. Well, we haven't quite done what they told us to do because they said we want no powers greater than 1. So we got to do the same thing again with this cosine squared guy. So cosine squared 2 theta. This is going to be 1 plus cosine 4 theta. Did you just belch really loud? And then 5 times all this, I'll have 5 over 2 plus 5 over 2 cosine 4 theta. 5 plus 5 over 2, that's 15 over 2. Why?
No worries.
You think you have worries now?
Oh, I know you do worries.
When I was 15, I had worries.
Oh, I have worries, but I have
Yeah. So enjoy this part of your life where you really don't have.
I live in
You had more worries.
All right.
I
So
meant like, what am I doing?
15 over 2 minus 10 cosine 2x plus 5 over 2 cosine 4x. Boom.
Well done.
Wait,
And
don't move on.
and in case this seems silly to go through all that work, actually, if you choose to take calculus 2 at some point in your future,
I'm not doing that.
I
You're
just
not
thought
doing-
I don't have
not
to be
doing
calculated.
okay. Well, this is something that you have to do in calculus 2 a lot because powers of trig functions are very hard to work with. Trig functions at multiple angles in calculus are very easy to work with. So, well, let's do one more like that. Just because you're going to be annoyed whenever you have to do it yourself, and so I'm trying to show you that it's really not that hard. So 112 sine squared of x, cosine squared of x. You're going to be annoyed. So is your face. So is your mama.
I know, I'm scared.
Okay, so sine squared x. Actually, this one's nice because when we fool, like half of it canceled out, right? Sine squared x is 1 minus cosine 2x. Cosine squared x is 1 plus cosine 2x, right? So on the bottom, we have 2 times 2 is 4, so 112 over 4, which is like 38 or something. No, it's not. It's 28. Yeah. And then I'll have 1 minus cosine squared.
I was pretty nervous about that one.
I did. What did you say?
I don't want to
Something tells me that.
Probably don't want to.
Yeah. All right. Just for the chagrins of it, what's 1 minus cosine squared?
Isn't that sine?
Yeah, that's sine squared. So this is 28 sine squared of 2x And we go one more time. Sine squared is 1 minus cosine. Now it will be 4x over 2. So 14 times 1 minus cosine 4x. And then distribute. Y'all can distribute that. That's easy.
You know.
I know. I have full faith in you.
I was on the opposite. I was
What?
we got on the one.
Yeah.
All the performers to be
Why?
bad.
I didn't watch it. I don't watch it.
Okay. So sine 15. Well, again, sine squared is 1 minus cosine over 2, right? So I'm going to go, let me go ahead and grab the paper again. So sine of 15 is going to be plus or minus square root 1 minus cosine of 30, not 3 theta, plus over 2. What's cosine of 30? Square root of 3 over 2. And sine of 15, 15 is in quadrant 1, so it's definitely going to be plus. So we got 1 minus root 3 over 2 over 2. Just to make it a little prettier, I'm going to multiply the numerator and denominator both by 2, or square root of 2 rather. So on bottom, square root of 2 just becomes 2. On top, square roots just multiply, so 2 times 1 is 2. The root, that cancels. So square root of 2 minus square root of 3 over.
Oh my god, no that's his talk.
No one asked you to talk either.
What is that?
He started it, actually. He did.
I feel like everyone's been.
There was TRIG the Angel Sassy, is that what you
It's being mean lately. Like, I don't know why.
You're rubbing off on him.
I don't know.
It's bad.
Okay, find the exact value of the trig function. So, tangent, we have all sorts of options to choose from. We can use sine over 1 plus cosine, 1 minus cosine over sine, square root.
Can I say something like completely random real quick?
Sure.
The left side and the bottom side are the same length, yet the left side is like 7. Yeah, the bottom side is like
They're not really the same lengths, but yeah, I mean, it definitely is not drawn to scale. And the bottom is a little longer than the left side is. But
Should be like that.
yeah, it should be like, if the bottom was 24, the 7 should be like 20 or something. Whatever it is, yeah. But sure, anyway. So let's go 1 minus cosine over sine. Why not? So, they're all basically the same. So tangent theta over 2 is 1 minus cosine theta over sine theta. And our picture, I'll try to make the bottom longer for Alana's sake. 7, 24, 25. And where was the theta's in that corner? Okay. So 1 minus, what's cosine theta equal to? Well, just the cosine. Yeah, 24 over 25, right? And sine theta is 7 over 25. So I multiply by 25 over 25. So I've got 25 minus 24 over 7, which is 1 over 7. Bless you. That's some sneezing you're doing there. I've always been a pretty violent sneezer as well. So, Verify the identity.
Venus is funny.
Okay. So, we're going to start with, it says use the half angle formula, so obviously we're starting with the tangent squared. So there's 3 formulas for tangent theta over 2. Only one of them has a square root in it. I want to use the one with the square root in it because then when I square it, the square root will go away. And I feel like life will be happy. So which one has a square root in it? Or rather, what is inside that square root? There we are. What is inside the square root for tangent of theta over 2?
1 minus over 1.
There we go. Yay. Oh, is it not on there?
Well, it is. They just didn't put the square root symbol.
Oh. Did I write the other? Did I really not do that?
It's just.
Okay, yeah. So instead of writing square roots on all of them, I put squareds on the other side.
Oh.
All right. And then if I multiply the top and bottom by secant theta, and I do not simplify, well, I'm just going to multiply all 4 guys each by secant theta. So I've got secant theta minus secant theta cosine theta over secant theta plus secant theta cosine theta.
That was supposed to be simplified?
No, it says do not simplify. That's one we didn't.
Oh, okay.
And then the last thing is secant times cosine. Well, secant is 1 over cosine, so cosine times 1 over cosine is 1. So we use the quotient identity to just get 1s. Oh, sorry. Reciprocal identity. Sorry, quotient identity is tangent is sine over cosine. You're at the left, so this is we're getting that one. We're at the left side in terms of sine cosine. Okay, so we've actually already did one exactly like that. We did tangent x is sine 2x over 1 plus. I don't know if we. No, we didn't. We did the one with 1 minus cosine on top, didn't we? Okay. So anyway, this is sine x over 2. Over cosine plus you x over 2. Now write the half angle formulas. So 1 plus or minus squirt 1 minus cosine minus cosine x. Oh no. Crap. I can't even do it that way. Okay, fine. I have to start all freaking over. Square root that now 1 minus cosine x over 2. And then same thing. Actually, Control A, Control C. The keyboard hates me.
Damn.
Not nice at all.
And now we have, okay, well, the over 2's cancel, so I have 1 minus cosine over 1 plus cosine, as I should. And now we're going to look at this guy, say, okay, well, which one leads to that, basically? It would be that one. Right, because 1 plus cosine, 1 plus cosine, sine, and sine squared is 1 minus cosine squared. And then, so use Pythagorean identity to simplify the radical. And then the last thing you have to show that the signs all work. It's kind of a pain, but it's not too bad. How many questions are there? 44. We're about halfway through. Okay, let's do this one and we'll say we're done for today. The relationship between a cone's vertex angle theta and the Mach number m. Dude, we get to talk about like Mach speed. Hey, there's guys in here, so that should be exciting. So bear with us, all the non-guy people. All right. Flying faster than the speed of sound is given by sine theta over 2 is 1 over m. If theta is determine the Mach speed of the aircraft. Okay. That's really simple because we had actually already done it. Because theta over 6 is what is a degree? 30. So theta over 2 would be like 15. And we already did that. And it's going to take a while to let me start scrolling. Bless you. This thing scrolls upwards really easy, but doesn't, when you go back to it and want to scroll down, it doesn't always do that. Or tangent theta, okay. Yeah, we already did this. So sine 15 was plus or minus 1 minus cosine 30 over 2. Cosine 30 is root 3 over 2, so square root of that. So this is 1 over m. So m is 2 over square root. And I'm going to guess they'll let me type it in like that. It doesn't say rationalized denominators. So. And then what is that as a decimal? We want to know like how fast we're really going. So 2 minus 3, whoops, no, minus 3 square rooted equals, that's the denominator, except I need to square root it. And it's in the denominator, so I need to 1 over x it, and then times 2. So 3.9 do Mach 3.9. Do you want to go Mach 3.9 an angel? Okay. I'll let you do that.
Can you scroll up a little?
Scroll up. Oh, there.
Yeah. Thank you.
Excuse me. Okay.